Lesson 23, 24, and 25 is what we're going to look at in this session. Lesson 23 is graphing different exponential functions. And you're going to be given equations like this, this, and this. Even though this says f of x equals 5 to the x, you can still put y equals 5 to the x in your calculator. But all three of these you can put in your calculator, and then you can graph them. When you graph them, you're going to get similar to these right here. You can label some of this, put what it is. You can see it in your book, what it is when you graph it. The only key to graphing in the calculator is to make sure that you don't make an error with the keys. So it's important as you do your homework to learn how not to mess up with the keys, maybe your window or different things like that. We could look at that in class. But graphing these are very easy and does not take long with the calculator. The first part of lesson 24 you already know how to do. It's adding different trig functions together. That is not difficult. The second part of lesson 24 is combining functions. So we already taught this concept. We laid the foundation for it. Now we're going to learn how to combine these. I'll show you the first example, then we'll look at the next one. Together it might be a little more practical. This one, they give you two different functions here. They say f of x equals log x, g of x equals x squared plus 6. Then they say g, this little symbol f of x. And so this is going to be an abstract because they gave you a letter here and not a number. This is your base equation. This is the one you're plugging into. That's what this little symbol means. It means you're going to plug the second letter equation into the first letter equation. So the g of x is going to be our base equation. So we're going to have that squared plus 6. So it's going to look just like that is over there. GOF of x equals that. This is our base equation, and we're going to plug this into our base equation because the f of x is going to be the one that gets plugged in. So we have log x. So GOF of x equals log x squared plus 6. So you could really just bring the squared here, and this becomes the answer to this. This is an abstract. At this point, you're not going to be solving for logarithms, but obviously because they threw it in here, it's something we're going to be learning very soon. But that is a simple version of combining exponents, or an abstract version, and then let's look at reality. This is more of what you're going to be looking at in your lessons. Is they're going to give you two equations, f of x equals x plus 2 and g of x equals x squared plus 3. Then they're going to give you 4 different combinations on how you're going to combine these functions. So this combination of a is f plus g 6. Then this one is f minus g6, this one's f times g6, and this one's f divided by g6. So what you're going to do in all of these is you're going to first come up with an answer of 6. So if we plug in 6 here, we plug in 6 here, let's get an answer. So 6 plus 2 is 8. So the f of x answer when plugging in 6 is 8. The g of x answer when plugging in 6 is going to be 36 plus 3, which is 39. So here are the two answers to these equations when you plug in 6. Now, let's add the answers for a. 8 plus 39 is going to be 47. And then let's subtract f minus g. That's going to be negative 31. Let's multiply 8 times 39. I don't have a calculator on me. 72, 24, and then we'll add 7 to that. It's going to be 3, 1, 2. I believe that's 312. You have the calculators. And then f divided by g is going to be 8 over 39. So there's the 4 answers to those, and I'll look them up really quickly for you. 47, negative 31, 312, and 8 over 39. Good. So that is combining functions. In lesson 25, we're going to be looking at word problems. In the first example on page 178, it says, the first one is going to be age word problems. It says, 10 years ago, Thomas was twice as old as Patricia. So, Thomas minus 10 years ago, Thomas. So this is how you write someone's age 10 years ago. Thomas minus 10 was twice as old as Patricia. It doesn't say minus 10, but this whole concept for the first sentence, first equation is we're talking about 10 years ago. So everybody's age is going to be 10 years ago. 5 years from now, Thomas will be. So 5 years from now, so it's t plus 5, Thomas will be 10 years older than Patricia. So P plus 5 plus 10. That's how he's going to be 10 years older. How old are both people now? When you solve for this, you're going to get the age of everybody. So we get t minus 10 equals. So t minus 10 equals 2p minus 20. And then we're going to get t plus 5 equals p plus 15. And so we have two equations here. Let's organize these a little bit better. So with the top equation here, we can bring the t and the p to one side. Minus 2p equals, bring the 10 over here, you get negative 10. Same with the next equation, t minus p equals positive 10. Now the thing that I'm going to do is I'm going to change the sign of everything on top. That way the t's will eliminate. You get p equals 20. That's not too bad at all. And if you go to this equation, if p is 20, bring it to the other side, t is going to be 30. So there are their two ages right now. The last part of lesson 25 are two different rate problems. The first one is rate times time plus rate times time equals jobs. Another one is rate times time times workers equals jobs. So R stands for rate, T stands for time, J stands for jobs, and W stands for workers. These are two formulas that you need to put on your formula page. Let's look at the first example on example 25.2 on page 179. It says Joe Frank can wash 3 cars in 5 hours. And then the other one is Merle. Love these names. So we have Frank and Merle. The rate of Frank equals 3/5. The rate of Merle equals 4/3. 15 cars need to be washed. So we got 15 jobs that need to get done. I guess I can leave that up there as jobs and put 15 need to be done. If Joe Frank works for 2 hours and is then joined by Merle. So this Joe Frank is going to work for 2 hours here. I'm just writing that down. And then he is going to be joined. How long will it take them to do 15 cars? Okay, so the rate of Frank is 3/5. The time we don't know. That's what we're going to be figuring out. The rate of Merle is 4/3. Once again, their time we don't know. And it's 15 cars originally that we're going to have to be work on, except for Joe Frank has been working 2 hours. And if he can do 3/5 of a car per hour, so that means if he works 2 hours, he's going to be 6/5. So we're actually going to have 1 1/5 car less than the 15. So we're going to have 13 4/5 cars still to work out here. So that's the key, is making this little adjustment here, because dude worked for a couple hours, so he did get some of this overall 15 knocked down to 13 4/5. That's what you have to figure out first. Then it's easy. 3/5 plus 4/3, you have to go to 15ths. So that's going to be 15, no, that's going to be 9 over 15 here. And this is going to be 20 over 15. So you have 29 15ths t equals 13 4/5. So you got to go to an improper fraction here. 13 times 5, that would be 6. 5 would be 5. 65 plus 4, 69 fifths. You're going to flip this one, bring it to the other side. 1, 3. So you flipped this and brought it to the other side. T equals whatever over 29. It would be 69 times 3 over 29. This will be the time. This will be how many hours it takes to solve for this. And it ends up being 207 is what that multiplies out to be. 207 over 29 hours. That's how you solve for those. The last example that we're going to look at on lesson 25 is rate times time times workers equals jobs. And what they tell us in the equation, they're going to give us a first scenario and a second scenario. And in the first scenario, they'll give us everything but one of the missing pieces here. And that'll be a standard that you keep for the second scenario. So in the first scenario, they tell us that 5 workers can do 1 job in 5 days. So what is the rate is what they want you to solve for. Then in the second scenario, they tell you if you have 3 jobs in 7 days to do it, based on this rate, how many workers is it going to take to get that done in that amount of time, that many jobs in that amount of time. So let's solve for our rate. So it'd be 25R equals 1. It's going to take, our rate is 1 over 25. So when you plug in, if our rate is 1 over 25, the amount of days they're giving us is 7. They want to know how many workers can complete 3 jobs. So it'll be 7 over 25 W equals 3. Flip it and bring it to the other side. And this is how many workers it is going to be. It is going to be, don't know how this is going to work, but you're going to need 75 over 7 workers. Don't know how you have 75 over 7 workers, but that is the number.